Hi everyone, this is the pumping water problem out of swimming pool. There is this irregularity to the side part of this pool. So I sketched over here and using XY coordinate system sometimes is the best. And if you look at the other side, it is always a 15 no matter where you're looking at. So I hope you see that's a P part right there and there's a Q. That's a Q in there. So we need to calculate this L, which is this side in there. And this is always 15. Because of that, let me sketch it over there. This is a sheet of water, that green color there. That's L. We were talking about looking at the sideway. This is always 15. Because of that, the area, the surface area of this thing, AY, is simply 15 times Y. Not 15 times Y, 15 times L. Now, this being y equals 0 and going up all the way up to y equals 5, if I can figure out the length of L as a function of y, and that's going to be it, L as a function of y. That's our next goal. If you put it in there, and that's it. So if you look at this part in here, right-hand side, this left to end is always in this part, x equals 0. Just figuring out the x coordinate here gives you this length because it's horizontal length is the x-coordinate. So it's mainly about this line in here. And this part's easy. It's always x equals at 30 because here's 15, here's another 15. So that coordinate x here is always a 30. But as you can see, this part is changing. So it's about this line. This one is a 15 comma 0 because down there is a 15 units to that direction. Look at it here. What is this point? That point right there has x coordinate 30, y coordinate, as you can see, is a 3 in there, 3. So you have 2 points, and you can write down the equation of this line, y equals something, and what you need is x equals something. You resolve it. So there's that point, and 15 comma 0 is another point. So it's a rise over on what is the slope. Y coordinate is a 3 minus 0, x coordinate, and 30 minus 15, right? 3 there, 30 down there, 0 and 15. So that's 3 over 15, that's 1/5. So if you multiply 5, you get that here's a 5 and 3 1/5, makes sense. So that line y equals 1/5 of x minus, if you use that point as a point slope formula, minus 15 plus 0, that's that right there. If you use this formula right there, 30 comma 3, you will end up at the same formula. But this looks nicer. So what we need is x. X is the coordinate right here. That'll tell you how long this one is because that coincides with the x coordinate. So I multiply both sides by 5. Then I get x minus 15 is equal to 5 times y. And x is equal to 5 times y plus 15. So when y equals 0, as you can see down there's 15, y equals 0, 15 makes perfect sense. When y reaches 3, if you put 3 in there, it has a 15 plus 15, so it gives you 30. That is a 30 in there. So this formula perfectly works when y is in between 0, that's this lowest level in here, all the way up to that, actually over here, that's 3. When y is in between 0 and 3, this side length is going to obey this formula. At the bottom is 15. As it rises, it goes all the way up to 30. As you can see, if you put 3 in there, 30. But this x-coordinate, when y is greater than 3, if you go beyond y equals 3, this length L is always equal to 30. It never changes. Go all the way up to 5, it's a 30 in there. So x-coordinate is that. So we figured out the formula of L. So that is the formula of L as a function of y. So you can still use this AY and use this LY in there. So work of pumping this water out is lower part of the body of the water is y equals 0, all the way up to is a 5. I assume it is pumping it all the way up to the top of the pool. So that was 9,800. By multiplying to the volume AY, you get the weight, and all the way to the top is 5 and minus y and dy. You calculate this integral, and that's the answer. But we have a formula of ay, which is 15 times L. But this L has a different formula when y is in between 0 and 3 and 3 and 5. So if it is 0 and 3, and you can substitute that with this formula, 15 is already there, so I have to write 15. And L is this one, 5y plus 15, 5 minus y, dy. So that's going to be the amount of amount of work that requires to pump up the water all the way up to 3 meters above. And the rest of the part will be integral, beginning with a slice of water at location 3 all the way up to 5 will be 9,800 multiplied by 15 times L. This time L is always fixed to 30, so you switch to just constant function 30, 5 minus y, dy. So now from here, the numbers are ugly, but if you just expand that and factor out the constant and that linear, so you know how to find the antiderivative of these things. So I hope you appreciate the power of this XY coordinate geometry, even if all the cone problem you had in the other problems. And if you just put it into XY coordinate system and you look at the data and without using similarity, you can just solve things nicely. So it's coordinate geometry is pretty powerful. Consider using it, and this is my straightforward approach to that problem.